Next session, Accelerating Insights, Democratise Data Access with AWS. Welcome to the Accelerating Insights session. Data, unlike most resources, is not consumed by use. The key to extract all the value contained in your data is to make it available in an easy, governed, and timely way to all the right stakeholders. In this session, you will discover how to make this happen with AWS. We have with us Marco Walashi, Senior Solutions Architect of Amazon Web Services. Welcome, Marco.
Hi, welcome to this session titled Accelerating Insight, Democratise Data Access with AWS. My name is Marco Lasci, and I am a Senior Solutions Architect at AWS in Singapore. I joined Amazon Web Services at the beginning of 2020 as a Specialist Solution Architect to support the ASEAN customer in their data warehouse journeys. And I recently joined the team supporting our customers in the public sector. Before moving to Singapore, I was based in Italy and worked for HP and Teradata for almost 20 years, helping enterprise customers in EMEA and APJ to succeed in their large-scale data projects. Why are we here today? The constant evolution of the society requires that organizations act on a regular basis at a speed that wasn't needed in the past. But action should be based on the insights extracting from data. Failing to do so may lead to unintended and undesired consequences from the actions. Today, we will review the ongoing dynamics that make hard to achieve this with the traditional solution. I will then focus on the area I believe is foundational to succeed in the task of giving access to your data to all the right stakeholders. Democratizing access to data is key to enable the extraction of the value, all the value from all the data produced. At the end of the session, I will also briefly show some of the services offered by AWS that can help you to make this vision a reality. Data production is growing at an accelerating pace for organizations of every size. This has been the case for many years now, and there is no end in sight to this trend. We hear from our customers that a lot of the recent growth is coming from event data and machine-generated data, from sources like IoT devices, log files, clickstream data, and social media. The human-generated data today is a small fraction of the total. The new data sources share a common characteristic. They lack the mostly fixed structure that was common in traditional data sources. By now, you have probably experienced that classic data warehouse solutions were not designed or optimized for storing and processing all this new semi-structured data. With the structured nature of traditional data warehouses, analyzing unstructured data is a significant challenge. Even for structured data, traditional data warehouses face challenges to integrate in a timely manner a growing number of data sources with a frequently changing set of attributes. The common solution, or maybe I should say the common workaround, was the creation of multiple disconnected data marts serving the needs of different stakeholders. Something similar happened with the new data types. Many organizations have reacted to the growth of event data and data sources by adopting multiple big data technologies in addition to their existing data warehouses and data marts. Unfortunately, most organizations following this approach weren't able to extract the full value contained in their data. And this happened because of the technical complexities of integrating in the real world the data stored in multiple disparate technology stacks. The different pieces seem to fit together perfectly on the architecture slides, but the reality of integration in the real world proved differently. The end result was an increase not only in the number of data silos created, but also in the number of technology used. technologies that often require different management, security, and authorization approaches. So even with an increased operational cost, a greater risk profile, and the allocation of additional resources to activity that don't differentiate the organization, this is what at AWS we used to call undifferentiated heavy lifting. Even with all those investments, the value expected seldom materialized. Going back to a world where data is not the foundation of operational and strategic decision is not an option. In today's world, and even more so in the future, it is necessary to give access to large volumes of data to an increasing number of users. And the users are going to process the data with an increasing variety of tools. Before moving forward, I want you to retain a key fact. I am sure you have all heard countless times that data is the new oil. Data and oil share some important aspects. For example, both need to be processed carefully to generate their full value. But there is a very important difference between the two. Data is not consumed by use. Storing all the data in a central place seemed to be the solution to the challenge of the data silo proliferation. And for about a decade now, a number of organizations has tried to make this vision a reality by leveraging Hadoop technologies, especially the Hadoop file system that is able to store huge volumes of data in a single place at a price point that was never heard of. So many companies, often without a clear expected business outcome, start to save all their data in Hadoop. And unfortunately, after some time, many also realized that this was not enough. The way the data was stored made hard for most people without a degree in computer science plus one in statistics to use it. And even for the individuals with the right skill set, the process of using the data was complex and slow. In the end, the value expected from all that stored data in a central place didn't materialize once again, and many data lakes turned out to be only data swarms. True, the price paid was lower than with the classical storage area network solution, but still the return on investment wasn't positive. To avoid the creation of a data swamp, it's necessary not only to store the data in a central place, but also to make the data usable by as many teams as possible. The data becomes easily usable when the centralized storage is augmented with capabilities in 5 areas. Catalog and search, which is going to be the focus of the rest of this session. Transform and prepare, analytics and machine learning, security and governance, and data movement at scale. Data movement at scale is very important because specialized tools still have their place. The tools that provide these capabilities need to have 2 fundamental characteristics: elasticity and broad choice. With traditional on-premise solutions, data processing capacity planning needs to occur well before data growth. In the past, this was often just a minor annoyance because the rate of data growth was slow, steady, and fairly predictable. But even in this scenario, once new capacity was purchased, utilization remained low until the data volume grew. And once the data volume approached capacity, then performance experienced degraded, resulting in an inefficient allocation of monetary and human capital. Also, because of the rigidity in the offer of computing resources and processing tools, it wasn't uncommon to end up limiting people's ability to process data. The cloud gives to organizations of any size the ability to modulate both space and computing capacity on short notice to adapt to the circumstances and support the evolution of society's needs. Allow me to stress the importance of a diverse set of tools. Business users, data engineers, and data scientists usually don't share the same technical background, yet they are all extracting insights from data. Giving to each group of users their tools of choice to work with the data is key in democratizing the data access. This favors the productivity and motivation of the teams and creates additional value. To avoid the creation of a data swamp is necessary not only to store the data in a central place, but also to make the data usable by as many teams as possible. You have heard me stating earlier that catalog and search is very important. Why is that so? When you accumulate a great diversity of data, you need mechanisms to understand what data you have, where it's located, and in what format. This is metadata management. If the metadata is not managed properly or at all, the data is essentially lost. It's taking up space, but you have no means to put it to use. Good luck finding a specific file in millions of files inside your data swarm. A common issue holding back the use of data is, regardless of whether it is on-prem or in the cloud, the lack of solid metadata management approach from the onset. Retrofitting a data swamp with metadata after years without control is doable, but is a very hard challenge that requires strong focus and organization-wide commitment. FINRA, the Financial Industry Regulatory Authority in the US, oversees more than 3,900 security firms with approximately 640,000 brokers and processes about 6 terabytes of data and 37 billion records on an average day to build a complete, holistic picture of market trading in the US. And on busy days, the stock market can generate 75 billion records, twice as much. The way they are able to make all this data useful, whether to data scientists or business users or others, is through a metadata system they develop and open source called Herd. This is the same platform that is used by LinkedIn, for example. But most organizations don't actually go off and build their own tooling. For example, Ivy Tech, a community college with 60,000 online and in-person course selection, 170,000 students, and 130 locations, uses metadata capabilities provided by AWS to manage their information. And you can always build additional capabilities tailored to your unique needs in an incremental way, starting from the foundation of AWS services. AWS Glue is a serverless ETL service that provides functionality spanning multiple areas. The fact that Glue is serverless means that you don't have to invest in server sizing, procurement, and management. You just get the processing power you need when you need it. The main component of Glue include a data catalog, which is a central metadata repository, an ETL engine with a graphical interface that can auto-generate Python code. This is code that is entirely customizable, reusable, and portable. You can just share it with others using GitHub or editing with your favorite tool. It also provides a flexible scheduler that handles dependency resolution, job monitoring, and retries, and a tool called Glue Data Brew to analyze data to find anomalies and clean the data if needed. Together, these components automate much of the heavy lifting involved with discovering, categorizing, cleaning, enriching, and moving data. So you can spend more time analyzing your data and less time managing it. The data catalog is populated through Glue crawlers, and I'm going to briefly describe them now. Glue crawlers automatically discover your data, determine the schema, and populate your data catalog. Data including Amazon database services, Amazon Redshift, DynamoDB, a distributed low latency NoSQL database, and Amazon S3, the object store service that you can use to keep any type of data of any size. The Glue Data Catalog provides also out-of-the-box integration with data processing services like Amazon Athena, a serverless analytical query engine, Amazon EMR, a managed Hadoop and Spark service, and Amazon Redshift Spectrum. This makes easy to process the discovered data immediately without further processing. AWS keeps listening to customer feedbacks about their experience in building data lakes. It emerged that there was a need to further help simplify and streamline the process of building data lakes. This is why AWS Lake Formation was created. AWS Lake Formation helps build and secure data lakes in the cloud in days instead of months. With Lake Formation, you can move, store, catalog, and clean your data even faster than before. You simply point Lake Formation at your data sources, and Lake Formation crawls those sources and registers the data with your Amazon S3 data lake for analytics and machine learning. Lake Formation also transforms data into open formats like Apache Parquet and ORC so that it can be analyzed without further transformation or preparation. And these open formats give you the flexibility to analyze your data efficiently using a broad set of analytical tools and services that best fit your workload. Data is important, is precious, and is a sensitive resource. With traditional data lake solution providing access to the right data to the right people and auditing the use was primitive and cumbersome at best. Lake Formation helps you not only to easily search your data assets after making a catalog, but also to control and audit the access. This session was just a little appetizer, but I hope you find it helpful nonetheless. In this slide, I'm sharing a couple of pointers to get started with Amazon Glue and Amazon Lake Formation, but there is much more we offer to databases, analytics processing, machine learning, and much more. We have many more resources to help you jumpstart your data democratization journey on AWS. These include technical documentation, white paper, and blog posts, and also in-person training, both for technical and business stakeholders. And we also offer certification programs for your developers. We are available to conduct joint workshops with you to help identify the best use cases for your business. And then we can work hand in hand with your teams to develop a proof of concept. Lastly, we have a professional service team as well as a very large network of partners who can even do end-to-end development for you and bring the solution to production. Thanks again for attending this session. My name is Marco Lasci, and I'm looking forward to see you succeed in your data democratization journey.